Hello everyone, welcome back to PMAC1105. In this video, I will be talking about how to solve rational equation. That's the first part of the video. And the second part and the third part of the video, I will be talking about how to solve rational inequality and the application of a rational function. Okay, so let's get started. So I'm going to put over here section 5.3. Rational inequality, rational equation, inequality, and application of rational function. Okay, so let me go to the first part of our lecture, which is a rational equation. Hopefully you guys still remember what I say. Rational equation is just an equation that contain fraction, because the rational is usually come from the word ratio, right? However, it's not just a fraction, but the variable must be under denominator. So last time I give you an equation that contain a fraction, but the variable x is still on numerator. If the variable x is on the numerator, we still consider as the linear equation. But if the variable x is under denominator, then we don't call it linear equation anymore, but we call it rational equation. Okay. And the general approach of how to solve rational equation is we have to find LCD. I mean, we need to bring it to the same denominator. Remember, every time we want to combine fraction, right, we must have the same denominator. If we don't have the same denominator, we cannot add or subtract, right? So the general approach is that we have to bring it to the same denominator. However, before we can bring it to the same denominator, I always recommend students to factor as much as you can. Okay, you have to factor everything out. You have to factor the top out. You have to factor the bottom. Most of the time, at least you have to factor the bottom of all the fraction as much as possible. Okay, so let me jump to the first example right here. Example number 1. I have an equation like this. I have x over x minus 2. You see that I have variable x on the top, but at the same time, variable x is also on the denominator. That's why we call it rational equation. Okay, so in order to be called rational equation, variable x must be at the denominator. It doesn't have to be on the top, but it must be at the denominator. X plus 2 equal to 8 x squared minus 4, for example, in this case. So over here we have this fraction here, and we cannot factor them all. This one we can factor either. However, you see that this fraction here, this is the difference of square. You remember the formula: a squared minus b squared is a plus b times a minus b. So you have to factor everything out as much as possible. So I'm going to just go ahead and keep this for the time being. So that's the first step you have to do. You're going to go ahead and factor everything out. So it will be x plus 2 times x minus 2. So after you factor everything out, then you're going to have to find LCD. So in order to find LCD to combine these two fractions over here, the LCD must be what? The LCD will be x minus 2 times x plus 2, right? Remember, if you have just a quick recall here, we have if we have 1 over 3 plus 1 over 2, the fraction, the LCD will be what? LCD in this could be 3 times 2, which is 6, right? So same thing over here. We have the first denominator and second denominator. So the LCD must be the product. Okay. So after we already know LCD, we're gonna go ahead and multiply the top and the bottom over here. So the LCD is this, right? So if you look at the denominator, x minus 2, they're missing the x plus 2. So I'm gonna multiply the top and the bottom by x plus 2. So there you go. I'm going to the top and the bottom by x plus 2. I'm going to use different color here. Okay. And over here, I'm going to multiply the top and the bottom by x minus 2. Okay. Oops. So x minus 2. So plus 1 x minus 2 over x plus 2 x minus 2. Right. Oh, I should use a different color right here. So let me erase and use different color so that you know that this is the new thing I just multiplied. So x minus 2. So I erase this. Okay. And over here will be x minus 2. Okay. Equal to, right? Equal to 8 over x plus 2 x minus 2. Alright, so we have the same denominator already. Now we can combine them. So we're going to combine it as one denominator only. Okay, and now on the top we're going to go distribute it. So we have x squared plus 2x plus the 1 distribute give you x minus 2, right? So distribute this in. Alright, split them in. And this is over here we have 8 over x plus 2 x minus 2. Okay. Alright, now you see that two fractions equal each other, right? And the same denominator. Here the same denominator. See this denominator of these two fractions is the same. It means what? It means that I can set up the numerator equal each other. So this is the numerator of the first fraction, and this is the numerator of the second fraction. So I set up equal each other, and I just go ahead and combine items. So I have x cubed plus 3x minus 2 equal 8, right? And I'm going to subtract both sides by 8 because I see that this is quadratic equation. I'm going to have everything to the left hand side so that I can have 0 on the left hand side and 10 equal 0, right? Now this is quadratic equation. Now we can go ahead and factor them. So we have x over here and negative 5 here and 2 over here, right? So this is everybody know how to factor this. Then I come up apply a zero product property. The property we already say right on first session of the whole semester, right? So I have x minus 5 equals 0 or x plus 2 equals 0. So I'm going to solve it. Alright, solve that. And I always go back and check. Let's see which one is the correct one. And after I've looked at it, I see this is not good. So this is not good. So look like most of the time we have 1, but you know you have to check. You always have to check. Okay. So this will be your final answer. Okay. Your final answer. So you basically that is how you should solve rational equation. You find LCD, okay, but you have to factor as much as possible. I'm gonna give you another example. Let's see. All right. So how about this one? Example number 2. Okay. Use different color. Let's use alright, I think I'm gonna keep using the white color. You know, this white color is good. Okay, example number 2. Okay, so I have something like this, and it's just a little bit hard, but it's not really that hard. Okay, so I have x plus 3 over here. So you see this fraction, you don't have to factor anything else. So you have plus 4x plus 5, and you see this one you don't have to factor anything else either. And for this one I have a quadratic, okay, and you see that we have to check if it's quadratic can be factorable or not. Okay, if we can factor, then we go ahead and factor them. If we cannot, we just go ahead and find LCD over here. So let's see we can factor this or not. Okay, so I'm gonna just go ahead and rewrite this. So I rewrite this. So I have over here is let's see x plus 3 and x plus 5, right? Oh, kind of, it's very straightforward. And now I see that as LCD could be what, x plus 3 and x plus 5, right? All right, that's the LCD. So I will just go ahead and multiply it over here. So we're missing the x plus 5 here. So we're missing x plus 5 there. So I'm gonna just go ahead and put x plus 5 there. Okay, and over here I have x plus 3, right? And I just put the x plus 5 here. So I use the different color for the part I multiply the top and the bottom. Okay. Okay, and over here you have 4, and over here we're missing what? We're missing x plus 3, right? So we're missing x plus 3. X plus 3 here, right? Over here x plus 3, right? And over here we don't have to do anything because it's just a fraction, and we just go ahead and keep it over there because it's in the factor form already. Now we have the same denominator already, so I'm gonna just go ahead and combine it as one denominator. So you see the all the steps are kind of the same. So I distribute it. So distribute them. So I have x plus 5. Distribute them in. So we have 4x plus 12. Okay, equal to 2. X plus 3 and x plus 5. Okay, and we have the same denominator already. So we just go ahead and set the numerator equal each other, right? Okay. Now what? So we're gonna have what? So we're gonna have. Oh, this equation is even easier than last time. Last time we have quadratic, and this one we have only the linear, so plus 17, right? Equal to. Oh, I just want to check one more time if everything's good. All right, so we have 5x equals to subtract what's going to be negative 15, and x equal to negative 3. All right, let's plug it in. So negative 3 over here, negative 3 plus 3 equal to 0. So 1 divided by 0 doesn't work. So this one is not working. This doesn't work. Okay, this is not working here. So this is not working. So I can jump to final answer will be a no solution. Okay, no solution because this is not really working. So no solution. All right. Very good. Okay. And you can do the same for all rational equation. Just find LCD. But you gotta be good at factoring. If you're good at factoring, then you have to. Everything will be alright. Now I'm gonna do another example, but in this case, I don't have to factor. For example, I have the equation like this. Let me pick something that I don't have to factor. Okay, how about this one? I have this one seems to be easy. 1 plus 3 over x, right, and equal 5 over x squared. You see that this one you cannot factor anything. So basically, I just find LCD over here. So this is like 1 over 1. LCD is just multiply the top by x, right? So this is 1 over 1. So I just multiply the top by x and over here by x. So plus. Okay. Oops. Plus 3 over x, right? And we have 5 over x squared. So you have x over x plus 3 over x equal 5 over x squared. And it become what? Then it become x over x, and you have the same denominator already. So you have x plus 3 over here and equal 5 over x squared. Okay. Now again, you remember over here, as long as we have the same denominator, we can go ahead and set up the numerator equal to each other. It's similar to this one. You see, you have the same denominator. You can set up the numerator equal to each other, right? But the thing is that, see, I have a proportion right here, but the denominator is different. So that's okay. I just go ahead and multiply. I just go ahead and multiply. I just go ahead and multiply the top and the bottom by x so that it's the same, right? So I can do like this. Okay, so I multiply. Right now this is what I have, right? And I multiply the top and the bottom by x here and x here. Okay. Okay. Then I will have what? I will have x plus 3 over x squared, right, equal 5 over x squared. You see they have the same denominator already, right? So this is equivalent to. So I can set up the numerator equal to each other. Okay. So we have x squared plus 3x equal 5. So it means that x squared plus 3x minus 5 equals 0. Alright, so I don't have enough space, so I think I'm gonna move over here. Okay, so this I have this quadratic, so I can factor them. Let me see if I can factor this, and probably we cannot factor this. You see, and if we cannot factor it, just go ahead use the quadratic formula. So negative a negative 3 plus minus is b squared will be 9 minus 4a is 1, c is 5 over 2a, which is 2 times 1, right? So we're going to give you what? Negative 3 plus minus. So it will be 9 minus 20, right? Over 2. And so give you negative 3 plus minus, give you negative of 11, right? Over 2. And negative 1 equal I squared. So remember that. So I just want to put a recall right over here. So I squared equal negative 1. Okay. So over here, what it becomes? So over here, just negative 1. So square root of I squared be I. So you have negative 3 plus minus I over square root times square root of 11 over 2. Hopefully I got everything negative 5. Oh, here this is a little bit messed up. So it should be minus. So minus, so positive. Should be positive 29. I'm sorry. So it will be eraser. So it will be 29. This will be 29. So erase this. So it will be 29. All right. Here you go. Okay. And I squared equal to negative 1, we already learned in the previous section, so you guys know that. Okay, so on the second part of the video, so that's the first Roman. The second part, I will show you how to solve a rational inequality. Okay, and the way you show rational inequality is it's different from you show rational equation. Actually, it's totally different from showing any equation. Okay. Oh, sorry. I think I messed up with the spelling right here. So it should be I here, right, and like this. The method of solving any inequality, especially in rational inequality, is kind of the same as you solve quadratic inequality. You remember when you do quadratic inequality last in the previous video, you have to set up the table, the side table. Okay, so you do the same over here. You have to set up the side table. Okay, but before you can set up the side table, you have to bring everything to the left. I mean everything, okay? It means on the right hand side, it will be 0. It must be 0. Okay? It must be 0 on the right hand side. If you have something, then you have to bring it to the right hand side. Alright? For example, I have something like this. And I know right away that this is a rational inequality. For example, I have like x plus 2 over 2x plus 1 less than equal 1. This is rational inequality, first of all, because this is a fractional form. Secondly, you have variable under denominator. And I already say, right, variable under denominator, it means you have rational inequality or rational equation. And this is less than equal. So this is inequality. So we have rational inequality over here. However, in order to set the side table, in order to set up the side table, number 1 over here is supposed to be on the left hand side. Okay, have to, must be. So the general approach will be this. The general approach, I think that let me use a different color right here. So the general approach will be this. I mean, some of you doesn't want to follow this approach, that's fine, okay? But I think that you should, because I think it's worth for all the case. So first of all, the first step you have to do will be everything must be on the left side. Okay, and 0 on the right hand side, and 0 on the right side. Okay, and the second step is that you're gonna find LCD to combine fraction. Okay, then the third step will be you have to factor that fraction as much as possible. Okay, then the last step will be set up side table. Okay, set up side table. I'm going to show you how to set up the side table and how to put the side in the side table. Okay. Then you look at the last step is you look at the inequality. If the inequality is greater than, then we will use all the table. So you have to. If the inequality is greater than, then we have to look for the positive side. If the table is negative, then we look for if the question is negative, then we look for the negative side. Okay. So look for positive or negative correspondingly to inequality side. Okay. All right. So let's follow the step over here. Okay. So first of all, you see that number 1 is still on the right hand side, which is not good. So everything must be on the left hand. So I'm gonna just go ahead and subtract both sides by 1. Okay, subtract both sides by 1. So I have this, right? Then you see that I'm gonna have to find LCD. To find LCD between this, so LCD between these two will be there. It will be 2x plus 1, right? So I'm going to multiply over here the top and the bottom by 2x plus 1. So we have x plus 2 minus. Be careful, this is minus, so make sure you have parentheses for 2x plus 1. Okay. So multiply the top over here by 2x plus 1. Okay, so this is 1 over 1. So I kind of skip that step, but I keep saying that so that you know. So this is 1 over 1, and you multiply the top and the bottom over here by 2x plus 1. Then you combine them, and make sure you have the parenthesis because minus. If the addition, you don't have to put parentheses because this is minus, so you have to put parentheses. Then we're going to distribute the minuses. So you have x plus 2 minus 2x minus 1 over 2x plus 1. Less than equals 0. Okay. Over here, what we have? So I'm going to combine like term over here. So I have negative x plus 1 right over here. 2x plus 1 less than equals 0. Okay. So the third step will be after we find LCD and come to combine it. So the third step we have to factor, but the thing is this is we cannot factor this anymore, right? Because everything is good. Okay, there's no need factoring here, so we kind of skip this step. And now we're gonna set up the table. All right. But in order to set up the table, this is what you have to do. You have to find the value of x for the top and the bottom. So we need to find this. We need to find the value of x. So we're going to set it equal to 0. Okay? We're going to set it equal to 0 and you solve for x. Okay? So solving a rational inequality is kind of have more steps. Okay? So over here you can have x equal 1. Over here you have x equal negative half. Alright? So after you got these two values here, okay? So we're gonna put it on the number line, the table. That's what I mean. So you can put it on the table, okay? Okay, so I have the table like this, the number line. That's what I mean. So it's negative infinity here and positive infinity here. So you have the arrow like this if you want to include it, and you have between them is 0, but you don't have to put 0 in the middle. you just need to know that we have two values, and negative a half is on this side. It must be on the left hand side of 1, right? So you just kind of estimate, okay? As long as the order is good on the number line, to be okay. Because negative half must be on the left hand side of 1. If you put negative half on the right hand side of 1, it will be wrong. Right? So you see that these two values here is divide my number line into 3 parts, right? So this part, and this part. And I want you to notice one more thing. So you see right here x equal to negative a half, and it's under denominator. It's under denominator. I think I'm gonna put this over here. Negative half here and 1 here. And because this is under denominator, it means what? It means that you're not allowed to have 0 here, right? It means that the value x equal to negative half will be undefined, because think about it, if you put negative half over here, it turns out to be 0. So over here it cannot be 0. It can be 0. Okay, so I'm just going to put like this. Okay, it can be 0. Over here we can have 0, so this is still good. Over here we can have 1, because 1 is still 0. That's fine. But over here we're not allowed to have 0 under denominator. Okay, so we're not allowed to have 0 under the denominator. It means that x equal to negative half here is undefined. So it's not gonna it's undefined. So I'm gonna put kind of 2 bar like this to tell you that this is undefined. Or you can put like this, the symbol like this, you know. But I mean, it probably we have mistaken with no solution, so I don't want to use this. Okay, so let me put 2 bar right here, mean undefined. Okay, but if you put 1 over here, right, 1 negative 1 plus 1, it's still 0. So this is oh, I'm sorry, I just deleted accidentally, so I'm gonna have to redraw it again. Okay. So at 1 over here is still 0, so I'm going to put 0 here. Okay. So you see that my two value over here is divide the whole number line into 3 parts. This part, right? Now we're gonna pick a number between in each part here and check for the positive and negative positive. Okay, this is 1, right? So I'm gonna pick any number. For example, I want to pick 2. Okay. And I plugged over here, so 2 over here, negative 1, negative 2, right? Negative 2 plus negative 1, 2, 2, so it will be negative, right? So this is going to be negative, right? And I'm going to pick something between negative half and 1, so I'm picking 0, so still it's turned out to be positive, right? So I'm putting 0 over here, 1 over 1 positive, and I put something like negative 1, so negative 1 over positive with 2, right? Negative 1 over negative 2 will be negative. Right, you can pick any value as long as it's less than negative half, and over here you can pick any value as long as it's greater than 1. So I pick negative 1. Negative 1 is less than negative half, so negative 1 times 2 is negative 2 plus 1 negative. We have positive will be 2 over negative 1 could be negative. So I have negative, positive, negative. So I already get all the sign for the table. All right, so which one we're gonna take? Which one we're going to take? So look at this. We have less than or equal. It means that we're going to take the negative one. We're going to take the negative one, okay? So we're going to take the negative one. So it means that all the value, all the interval right here, we're going to take. All the interval over here, we're going to take, because we want to take the negative one, because it's less than equal, right? Less than equal, and this one can be equal, and it's equal sign. So after I got the interval already, okay, so we're gonna get our final our final interval notation. So the answer for this interval, for this rational inequality, will be negative infinity and negative half, and we're not allowed to have a bracket here, even though that we have the equal sign, but because this is under denominator, so we have to put parentheses. Union this one, we can put a bracket because we allow to have 0. We allow to have 1 over here, 1 over here. It's still good. So this is 1, a positive infinity. All right, here you go. Okay. All right. So let's do another one. Let's do another one. I know that's kind of one example is not enough, you know, because that's why I'm gonna give you more. So probably some of you still have trouble finding the sign right here, but that's okay. Let's do another one. So example 2. Okay. How about this one? 1 over x minus 1 over x minus 2 greater than 2. Okay, greater than 2. Okay. Again, I'm gonna bring everything to the left. So I'm gonna have 1 over x minus 1 over x minus 2 minus 2 greater than 2. Now I'm going to find LCD for every fraction here. Or you want to find LCD for the first 2 fractions, then find LCD for the last one. It's up to you. But I think I'm going to go ahead and find LCD for everything. The LCD for this will be x and x minus 2. So over here you miss x minus 2, so I'm going to just go ahead, multiply the top and the bottom by x minus 2. Right. Okay. Then over here you miss the x, so I multiply the top and the bottom by x. Okay. And over here you miss the both x and x minus 2, so I'm going to multiply the top. Okay. By x minus 2. Okay, x minus 2. Alright, now I'm going to put everything greater than 0. Okay, so everything will be in, it had the same denominator already, so I'm going to just go ahead and write it. There's one denominator. So you have x minus 2. So over here, so you have 1 time you distribute, so it will be x minus 2 minus x, right? Plus, so what distributor means? So for distributor, everything will be the minus 2x squared, right? X times x squared, and plus 4x greater than 0. Okay. Now we can combine like terms. So x and x over here cancel out. So you have negative 2x squared plus 4x minus 2 over x minus 2 greater than 0. And I say, so after we combine them already, we have to factor them out as much as possible. So I'm going to factor, I'm going to factor negative 2 out. So I have x squared minus 4x. Is that plus 1, I believe so? There you go. Okay. Oh, this should be, I think if I got it wrong, it should be 2. Okay. And over here will be x minus 2 greater than 0. Okay. So you see the problem over here is that we don't want the negative over here. So we need to get rid of the negative 2 over here. I'm going to go ahead and divide both sides by negative 2, but remember, for inequality, when you divide both sides by a negative number, you have to flip the sign. So after I divide by negative 2 both sides, okay, my inequality will be something less than 0, like this, right? Because the 0 be divided by negative 2 should give you 0, okay? Now, our job now is to factor this as much as possible. So I'm going to factor this. It's easy. This is x minus 1 squared, right? Okay, x minus 2. And now see that everything is already in factor form. everything is already in factor form. So our job now is to put it on the number line. But before putting it on number line, you remember we had to find a value, right? We had to find a value to put on the number line. So I'm going to find a value. Okay, now I'm going to find all the value to put on the number line. So it means that I'm going to set each of them, right? Because everything in factor form already. So I'm going to set each of them equal to 0. Okay. So the first one equal to 0, x equal to 0, and x minus 2 equals 0. So x minus 1 squared equal to 0. It means x minus 1 equals 0. It means x equal 1. This one is done. So that's x equal 2. Now we're going to put this on the number line. So we have 3 values here. So I'm going to put it on the number line, okay? Alright. Infinity here, positive infinity here. So make sure you put everything in order. So you have 0 first, so you have 1 over here, right? And you have 2 here. Okay, so we have to see. I think I'm going to put on the top instead of put at the bottom. So I have 0 here, 1 here, and 2 here. Alright, so we have to see which one give you 0 on the denominator. So it give you 0 on the denominator for these 2 values, right? So over here is undefined. Oh, not this. Not this. It's this one. Over here undefined because 0. If 0 over here, 0 times 0. 0 times everything will be 0. So undefined here. And 2 is also undefined here. But if it is 1, if it is what 1, so 1 minus 1, 1 square, 1 minus 1, 0, 0 square, 0. So this is give you 0 here. Okay? Give you 0 here. And again, we want everything less than 0. We want the negative sign. Okay? We want the negative sign. Not the positive sign. Okay? Even though originally we have the greater than. But because after we put everything in factor forms, this become less than 0. So it means that we have to find the negative part. Okay? So you have 4 intervals. So we're gonna check we have to find the sign for each interval here. So I'm gonna plug in the value number 3 here. So 3 3 3, you plug it in 3 3 3 3 3 1 3 minus 2. So it's really positive. So this is positive. And you put everything between 1 and 2. So we put a 1.5. 1.5 minus 1 is 1.5. 1.5 minus 2 will be negative. Right? So this will be negative. And you put a half. Put a half. So 1.5 will be 0.5 minus 1 is negative. It will be negative. Negative over here. Negative over here, and over here, but we use square to give you positive, so it'll be negative here. This positive, so be negative, right? Right, and this is less than, so I'm gonna put negative 1, negative 1, negative 1 over here, negative 2. You square positive, negative 1 over negative 3, negative times negative 1 positive. So this should be positive. All right, now we want to take it less than. It means what? We're gonna take this. Mean that we're gonna take less than, it mean this one. Okay, I mean this one. Alright, it is there. Okay, then my interval notation will be what? Will be, because we don't want to take 0, okay, so 0 undefined, so we have 0, 1, parenthesis, right? Parenthesis, we don't have bracket because over here is less than. Okay, union with 1, 2, parenthesis. And that's it. That's your final. Okay. Great. Let me see. I'm gonna give you another one because rational inequality is very important and it's kind of lousy a little bit sometimes. Well, I mean, you just have to be careful. That's all I want you to do. Just be careful a little bit. Okay. How about this one right here? Let's see. Something really kind of interesting, you know. So I'm gonna give you. Let me see. I have enough space right here. I think I'm gonna give you. Okay. Let's do example number 3. Okay. Example 3. Um, so let's say I have something like this. Okay, how about this one? How about this one? So let's see. I have I don't want to give you something really hard, you know. I just want to give you something in the book. It's kind of standard one. Um, okay, how about this one? Kind of interesting right here. My x to the 4 plus x squared plus 3 over x squared plus 2, right? Okay, and it's less than 0. Okay, so first of all, you see that everything on the left hand side already, and you have 0 on the right hand side. So look like you don't have to move everything. The second thing is that we try to factor them, but can we factor this? It's x squared plus 2. We can. And can we factor this? This is x squared, x to the 4 x squared plus 3. I mean, if you want to factor, if you can, probably you can in this case. But the thing is that if you use some kind of logic, you see that no matter what value over here you plug it in, is you raise to the 4, it's always greater than 0, right? Always. So x to the 4 is always greater than or equal 0. Right? And x squared is always greater than equal 0, right? 3 is always greater than 0, and x squared plus 2. So if you add all of this together, so it means what? It means x to the 4 plus x squared plus 3 is always greater than 0. Okay. Another second logic I want to have over here, the denominator x squared plus 2 is of course always greater than 0, no matter what. Even you plug a 0 over here, 0 squared 0 plus 2 is always greater than 0. So it means you have something greater than 0. You divide by something greater than 0. So you have something greater than 0. You divide by something greater than 0. Then your answer must be something greater than 0, right? Oh, of course, right? It must be, all right. And they want to find the x value that's less than 0. So this doesn't make sense, because no matter what value we plug it in, it's always greater than 0. But we want to find a value of x that's, we want to find some value of x that's less than 0. We don't have any. It means what? It means that our answer over here will be no solution. No solution. No solution. Or we can write like this: no solution. Okay. So this kind of some kind of logic I want you to have. Okay. Some problem you don't have to do anything. You just apply the logic. Okay. All right. Now let's do another example. Example 4. How about this one right here? Let me see. All right, this one I have a problem like this, and this problem look like they have everything on the left hand side already too, and look like they combine everything for you already. So you have x squared minus 1, and they multiply by 3, and minus 3x minus 1 multiplied by 2x. Okay, and at the bottom we have x squared minus 1, and everything is square, and they want it less than or equal to 0. Alright, so everything on the left hand side already. But the thing is that it's probably not in factor form, right? So in order to put everything in factor form, or put it something that you cannot even factor, then you go ahead and distribute. So you have 3x squared minus 3. This give you negative 6x squared, right? Negative number gives you 2x, right? Over x squared minus 1 square. less than or equal to 0, then this is equivalent to negative 3x squared, because you combine that term right here, plus 2x minus 3. Okay, x squared minus 1 square less than or equal to 0. Okay. Now I'm gonna just go ahead and factor the negative out. So I factor the negative out, so I have 3x squared minus 2x plus 3, right? Okay, less than or equal to 0. And I divide both sides by negative, so it means that I gotta flip the direction here. So you have 3x squared minus 2x plus 3 over x squared plus 1 square greater than or equal to 0. Okay. Now our job is to factor this. I just want to check again if I copy everything right. X squared minus 1, 3 minus 3x minus 1 times 2x. Okay, so negative, positive, x. Okay, so you have 2x minus 3, negative x squared plus 2x minus 3. You factor the negative out, so negative, positive. Okay, so our job here is to factor this. Let's see if we can factor this or not. Okay. Okay, let's see. So it means over here the factor is will be 3x, will be just 3x and x here. So we want to have some way somehow so that I have negative 2 here. And the factor of 3 is just from, oh, this is mine. I don't know why I changed this to positive. Okay, can we factor this? Not. Alright. Look like we cannot. Because no matter what I'm putting, so if I put 3, 1 over here, there's 1, 3 over here, doesn't work either. So this one you cannot factor. Cannot factor this. So you have to leave it there. So you have to leave it there. Maybe we just can factor the bottom. Alright, this is we can factor the bottom. So x squared minus 1 is x plus 1 times x minus 1, right? And you square everything, so you're gonna have something like this. Okay. Alright, so the top we can factor. We're gonna just go ahead and leave it like that. The best thing is that how we gonna check the sign for the top? We can check the sign here. So for this one is you have to be careful, because we know that x plus 1 square is always, we know that x plus 1 square is always greater than or equal 0, right? Or you can solve for that. So that's the value will be negative 1, right? We can find the value over here, because we if we set it equal to 0, right? So we're gonna have x equal to negative 1, and x equal to negative 1 is undefined. And for this one, we also know x minus square is greater than or equal to 0 all the time. And if we solve for the value, so we have x minus 1 square equal to 0, then x will be equal to 1. So the value so that the denominator is equal to 0 is x equal to 1. So it's undefined at negative 1 and 1. You see, it's undefined there, because negative 1 plus 1 over here 0 at the bottom, undefined. 1 over here 1 minus 1 0 over here at the bottom, undefined. Now we have to so look like on the number line we have to put negative 1 1. But how about the top? How about the top? We need to know the sign of the top. Okay, this is quadratic, and we must have two value there. Negative 4 AC. But the thing that you see that if we find let's find there's nothing over there. We don't have the, because look at that. If we find if we use the quadratic formula to solve for that, right? So the x must be equal negative b will be 2 plus minus b squared will be 4 minus 4 AC, right? So this is over 2a will be 2 times 3. This is an imaginary solution. Okay, and we know that this quadratic right here is opening up, and it's not cutting the x-axis. Okay, it's not cutting the x-axis. It means what? It means that it's always greater than 0. It always greater than 0, because the shape of this quadratic will be something like this. Something like this over here at 3 right here. See, this quadratic over here is always greater than 0. So the x over here, you see that? Is the y over here. Okay, so it's always above the x. So this is always greater than 0. It cannot even equal 0. So we know that 3x squared. So 3x squared minus 2x plus 3 is always greater than 0. It cannot even equal. Okay, it's always greater than 0. Okay, so this is greater than 0. Okay, now, so it means that we already know this. We know the sign of this. It means the positive sign right here. Okay, now we're gonna find a sign for this. So for this one, I'm gonna, the way you set up the table, it's just a little bit more detail. Okay, so I'm gonna do like this. Okay, I'm gonna do that. So I have negative infinity here, I have positive infinity here. Okay, and I just put these two values, negative 1 and 1, negative 1 and 1 here. Okay, but for the I'm gonna just divide it into 3 parts. The first part, I'm going to put the top. Okay. Then I put the x plus 1 square. Then I'm going to put the x minus 1 square. Okay. Okay. Then I put everything. Then I put 3x squared plus 2x plus 3 over x plus 1 square and x minus 1 square. Okay. Okay, so over here we know that it's always positive. So positive here, positive here, positive here, because we just said it's always positive. Okay, so x plus 1 is so right over here we notice it's undefined here. Okay, and for this one we know it's undefined right here. See, undefined at 1 right here. Alright, now we're gonna check the sign for this. So no matter what value we have, we plug it in over here, right? We square is always positive, so it's positive here. And no matter what value over here, including the negative value, you plug over here and you calculate, you square this. Again, it's always a positive. Okay, so you multiply these two, right? It's positive, so everything will be positive here, and will be positive here, and everything positive here. Okay. At negative 1 we undefined. At 1 we also undefined. Then my answer will be back. So we want to take everything greater than 0. I mean, we take all the let me use a different color, right? It means that we take all the positive one, right? So we're gonna take this, okay. But at negative 1 we don't want. It's not defined. So my final answer will be what? My final answer will be negative infinities at negative 1 union 1 negative 1 1 in union with 1 positive. All right, so that's the final answer. So for this one, it kind of a little bit special because you need to know, for sure this is positive all the time. And in order to check for that, you just go ahead and grab it, and you see that, okay, this is above the x-axis. I mean, it's always positive no matter what, right? No matter what value you plug over there. Okay, always positive. And the table, you see that I'm going to just split it up into 3 parts. It's not like last time. Last time it's kind of simpler. Okay, so this one you have to do a little bit more logical thinking here. Okay. All right. So I think that's it. And for this second part, on the next part, I will be talking about. So the third Roman, I will be talking about the application of rational function and rational equation.